Boom! All right. So we're in the third video in our series on binary operations. Now I want to go back to something that I would have mentioned in the very first video, where I made a distinction between the operation of multiplication occurring across three entities and the operation of multiplication occurring across two entities. So for example, if I have 8 multiplied by 4 multiplied by 2 multiplied by 3, or I have 8 multiplied by 4 multiplied by 2, none of these could be considered as binary operations, right? Remember, we started initially with 8 multiplied by 4. That is a binary application of multiplication. So here we have multiplication as a binary operation because we're multiplying two operands, two entities, two values by each other. That is not the case here. Here we have 3 values being multiplied by each other. That is not binary. Here we have 4 values being multiplied by each other. If, however, I do this, if I say 8 multiplied by 4, I put that in brackets, multiplied by 2, now we have a binary operation because we have 2 operands. So in this case, the operand is the value 2. In this case, the operand is a whole operation by itself. So you can have a whole operation functioning as an operand as well, within the context of an even broader operation. All right? So 8 multiplied by 4 is 32. So this will be what? 32 multiplied by 2. So binary here, and we still binary here. Right? In this case, we had a binary operation where the operand, the 2 operands were a value 2 and an operation 8 by 4. This operation, we now have to find the value, the final and ultimate value of that operation 8 by 4. When we do that and we get 32, now we have another expression of this in the form of this line here, which is now 2 values, 32 multiplied by 2, which will then give us the final value of 64. So yes, it is possible to have a binary operation where in its sum totality you have more than one operand. But if you manipulate the operation in such a way that you have 2 entities, then that is binary. This whole thing here multiplied by this whole thing here, this entity by this entity. 2 entities, 2 operands, even though in this case the operand is actually a smaller operation. Yeah? And we could do the same thing in reverse. So instead of putting it how we just put it there, I can also say 8 by 4. I can do that. Yeah, same story. 8, this here is an operation. So because we have 2 operands, the operand 8 and the operand 4 by 2, which is itself a whole operation, because 4 by 2 is a binary operation. 4 by 2, binary operation. This here is the operator. So what we do, we bring back the whole bombast thing, brackets of blah 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 going down the road. You deal with your brackets first. In other words, you evaluate, you determine the value of this operation, just as we did before. So you have 8 multiplied by 4 by 2 is 16. Sorry, 4 by 2 is 8. Huh? Yeah, a little slip like that happened. time to time, right? And I just want to take that as an opportunity to highlight that everybody makes mistakes. Simple mistakes like that. 4 by 2 is 16. Whew, 4 by 2 is 16. So there I was saying something and thinking something totally different, which is why you need to practice. 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 Because the one place where, as much as possible, to the best of your ability, you don't want stuff like that to happen is in the exam itself. Right? Because the opportunity for self-correction is limited. If you catch a mistake and you fix it, fine. If you don't catch a mistake, you harm the people with the mistake on it. Right? So, take your math seriously. And 8 by 8, of course, we know is our good friend 64. Alright? Let us now consider this guy here. So up there now, we have a situation where you have 4 operands and you have the same operator occurring 3 times. This here is not a binary operation because you have 4 operands. However, if you do this, if you say 8 by 4 in brackets and then you multiply it and then you say 2 by 3 and you put that in brackets, well then yeah, look it right there. Binary because they have 2 entities. You have 2 operands, both of which themselves are little operations, smaller operations. So you have this operation here, you have this operation here, all as part, in the grander scheme of things, of an even larger operations. Right? So maybe for linguistic purposes, you could refer to this whole thing here as the operation, and you could refer to this as a sub-operation, and you could refer to this as a sub-operation. If that helps in your own thinking on the matter, well then fine. You know, we always have to find, each of us, little ways and means of thinking these things that might be different to what other people might do. But once we get to the same answer, no problem at all. Yeah? Well, the same correct answer, that is. Alright? So 8 by 4 is 32. 2 by 3 is 6. So 32 by 6. So you see, operation, operation. Now we could refer to this as an operand, which carries a value. Well, this too is an operand. Eh? That's what I make the point. At each stage here, we have 2 operands. Just that at this level here, on this line, the operand is an operation. Here, the operand is the value, the result of this operation. Same story here. The operand is the operation. The operand here is the value, the result of this operation. 32 by 6 is what? 32 by 3 is 96. 96 by 2 is 192. So 32 by 6 is, yes, 192. Alright? 6 to the 30, 6 is 18 and 119. Yeah. You see? You could do that when you know your tables. You know your foundation tables. You can multiply things in your head. Alright? So don't fall into the trap of thinking that, well, I don't need to know my tables because I have a calculator. Well, I don't need to know my tables because I have a calculator on my phone. Listen, man. Nobody is expecting you to know 27 multiplied by 45 by heart. We're not expecting you to know that. Nobody is expecting you to be able to multiply 368 by 2,939 in your head. Nobody expecting you to be able to do that. But geez, man, 9 by 3, 4 by 8, 7 by 8, 6 by 9, 4 by 7. Your tables, your basic tables. Make an effort to commit those things to memory. Right? There will be times when the fact that you could do it on your feet. You run through certain things quickly. And quite apart from that, it helps to keep your mind sharp. Don't fall into the trap of depending on a machine to do everything. Even though we're in 2022, in the age of machines, there are things you could do with your own head, and there are things that you still have to rely on your interaction with a live human being to do. Yeah? Right. So that's it for the topic of binary operations. No, we ain't done yet. There I was getting all happy because we finished. We have one thing to do. We need to continue the same process with the unfamiliar operations. Now I want to make a point. Right? I want to make a point in the case of this guy here. Right? Because I don't want people assuming that because when we multiply, we got the same answer, it's going to happen for other operations. Now take this and listen to it very carefully. 8 by 4 by 2 is the same thing as 8 by 4 by 2. That is the associative property of multiplication. In the same way, 8 by 4 is the same thing as 8 by 4 is the same thing as 4 by 8. That is the commutative property of multiplication. I want to make this point, and I want to make it absolutely clear that this applies for multiplication. It also applies for addition. So if, for example, I were to say, using the same figures, 8 plus 4 plus 2, we put a bracket here, and that will be equal to 8 plus 4 plus 2. In the same way, we could say 8 plus 4 is equal to 4 plus 8. Right? Commutative. Let me write it down. Alright? This is the commutative law in action. Commutative law. The commutative property. This is the commutative property. Right? Commutative property. And then we differentiate and we distinguish that from the associative property. This here is association. Associative property. This here is the associative property. Right? Property. Right. I want to make it absolutely clear that this property applies to regular multiplication and regular addition. It applies to other things as well, which we will stay away from for now. However, in defining generic random operations, binary operations, in defining generic random binary operators, because for each operation that you define, you need a symbol, you need an operator for it. This property is not to be taken for granted for random binary operations and random binary operators. Let me repeat that. These two properties of association and commutation that we take for granted because they exist, that we take for granted for multiplication and addition and other things, do not make the mistake of assuming that other binary operations that we treat in the same way are also associative or commutative. Let me explain. So we do this for multiplication and we do this for addition. Let us use the same values with the operations that we defined earlier. So for example, if we have 8, right? Watch it now. We're maintaining the same pattern. If we have 8 star 4 star 2, we don't have, that is not a binary operation, right? But if we do that, then yes, we have a binary operation. And we want to compare that. Let me draw a little line. We want to compare that with 8 star 4 star 2. Right? Not because it happened for multiplication and addition, you're going to assume that it will happen for the star. We just call it star. Right? Because remember, we define this operation as a plus b over 2. So 8 star 4, we already worked that out as what? No, we didn't work that out. So let me do it now. 8 star 4 is what? This will be 8 plus 4 over 2. Let me say star 2. So you see, we're actually working out here the operation defined here, right, by this operator acting or operating on these two operands. So 8 plus 4 over 2 star over 2 is 6. So this will be 6 star 2. No problem. Over here, we're working it out first here on this occasion. So this will be 8 star, this here be brackets 4 plus 2 over 2. So this will be 4 plus 2 is 6 over 2, which is 3. So this will be 8 star 3. So you see, the associative property does not exist because the final operation is not the same in both instances. Now there may be specific instances where it might end up being the same, right? In fact, if you sit down and you give it enough thought, you could actually design an operation that ends up being associative, right? But that will be so because you specifically decided to make it so. That is not an inherent property of all binary operations, as it is with multiplication and division, not division, sorry, as it is with multiplication and addition when used in a binary sense, right? So I hope that this illustration and the one we're going to do after this will give you the hint that associativity and commutativity, association and commutation are not to be taken for granted when you're doing binary operations, because you'll get questions where you have stuff like this. You have 3 operands and you have the bracket that you'll put to make it a binary operation. Don't assume that this is the same thing as this, right? Because over here, 6 star 2 is what? Just to drive the point home, 6 plus 2 over 2, which is 8 over 2, which is equal to 4. And over here, 8 star 3 is equal to 8 plus 3 over 2, which is 11 over 2, which is equal to 5.5. Right? So you see for yourself, using simple examples, using the same values that we were dealing with before, that binary operations are not to be assumed as associative. Let us do the same thing now for the commutative property. 8 star 4 and 4 star 8. Let me see what we get. Aha! This one is commutative. So we will do the contrast between this one and the others. Right? Yeah, this is a nice example. Right? Pay attention. Because remember we defined A star B as A plus B over 2. So A star B is equal to A plus B over 2. And let me choose 1. Let me say let me say P. Nah, we could do it with these simple numbers, so we can run through it fast. Let me say M star N. Remember that was 1 over M plus 1 over N. Yeah, no problem, no problem. We have P circle with the cross with the X. Q was equal to Q squared minus P squared. And we have V star circle with the cross. W is equal to the square root of W minus the square root of V. Right. So 8 star 4 and 4 star 8. 8 star 4 is equal to A plus 4 over 2, and 4 star 8 is equal to 4 plus 8 over 2. In both cases, 12 over 2 will give us 6. Right? So in this case, yes, A star B is commutative. And the reason for that is because you have the addition here, which is itself commutative. So in that case, yes, the commutative property of the addition carries over and makes the operation as defined here commutative. But again, I want to drive from the point that is not always the case. Because if we come here now, no, let me do this one first, just to drive home the point. If we have 8 triangle 4, that is 1 over 8 plus 1 over 4. And then we have 4 triangle 8, that's 1 over 4 plus 1 over 8. And we know addition is commutative, so 1 over 8 plus 1 over 4 will give you the same answer as 1 over 4 plus 1 over 8. No problem again, because we have an operation here that is basically commutative. So if this is a binary, then this operation here would also be commutative. Life going to get nice now, because P circle with the X, Q would be what? 8 circle with the X, 4 would be 8 squared minus 4 squared, and 4 circle with the X, 8 would be 4 squared minus 8 squared. This will be what? 64 minus 16. This will be 16 minus 64. This will be 48. This will be minus 48. And then over here now, I just want to do both of them fast. Right? 8 circle with the cross 4 is equal to, no, my mistake. This here is supposed to be 4 squared minus 8 squared. 4 squared minus 8 squared, which would be, you see how careful you have to be? 16 minus 64, which would be minus 48. This here would be now 8 squared minus 4 squared, which would be 64 minus 16, which would be 48. All right, same story here. In this case, it will be the square root of 4 minus the square root of 8. Let me leave that alone for now. And 8, 4, circle 8 would be, let me use a perfect square. Alright, let me make life more interesting than that. Let me say 16, circle 4, this will be the square root of 4 minus the square root of 16. And this would be 4, special symbol 16, would be the square root of 16 minus the square root of 4. This would be 2 minus 4, which is minus 2, and this would be 4 minus 2, which is 2. Alright? Right, so simple examples, and you could test this with other binary operations that you will come across. You have commutation happening here, you have commutation happening here as well. This will be what? 4 plus 8 over 32. 12 over 32 is 3 over 8. 3 over 8, right? Yeah, 2 plus 1 over 8 is 3 over 8, right? 3 over 8 here, and 3 over 8 here. So in this case, in these two cases, you have commutation occurring, commutative property holds. So in other words, this operation is commutative, this operation is commutative, so you can say that this operator and this operator, both of them are commutative. The operation defined by these two operators are commutative once applied in a binary context, which will be here and here. Over here now, different story. This operation as defined by this operator is not commutative, because in one case you have minus 48, in the other case you have plus 48. Same story here. In one case you have minus 2, in the other case you have plus 2. Both of them essentially involve subtraction, which we know is not commutative. Of course, you could have other operations that are more complicated, and you will find that sometimes it's commutative, sometimes it's not. And in the case of associative property, which we just described, even less would be the times when you get a binary operator being associative. All right, so again, let me just drive home the point. Do not assume that binary operations are associative or commutative. All right? They may be so under special circumstances, but that would normally be the case. And that is what it is where this topic is concerned. All right, so I hope that you're here because you would have looked at all videos in their entireties. Right, as I say to my students all the time, the videos wouldn't always be exciting. I am not even trying to make the videos exciting. The videos wouldn't always be short, snappy, and within your range of concentration, right? The videos wouldn't always be within your attention span. So if your attention span is 5 minutes, I can't always promise you a 4-minute video. If your attention span is 3 minutes, don't expect my videos to be 2 minutes. The fact is, most of the things that enhance your life, most of the things that make your life better, the things that we generally would want because they make our life better. At some point, at some level, it is going to involve operating on a longer attention span. It's going to involve some kind of focus. It could involve some kind of discipline. So if you know that focusing is your problem, then that is something you have to deal with. Don't leave it unattended, because it's going to affect everything you do. Everything you do is going to affect. Right? Inability to focus is not an excuse. It is simply something that you have to fix. Yeah? Right, so let's keep good. Take care. So we finished one more topic. Stay tuned. We have plenty more things coming up.